Yo, 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 welcome back from fall break. It's nice to see you all again today. Hope you all are having a great fall, just like Humpty Dumpty, and are ready to get back into Chapter 4, starting Chapter 4. So this is solving systems by graphing. So Chapter 4 is about systems of equations. Chapter 3 was about linear equations, so adding on to this. Okay. So here's our Common Core State Standard. It says solve systems of linear equations, focusing on pairs of linear equations and two variables. We've got a bunch of vocab here to go over. So first, I want you to look at this problem, now that it's basically winter here, for the next 8 months. Two professional downhill skiers are racing at the speed shown in the diagram. Skier 1 starts 5 seconds before skier 2. The course is 5,000 feet long. Will skier 2 pass skier 1? How do you know? Okay, so I want you to think about that. Take some time. You can pause this and then we'll talk about it. Okay, so think about it. Pause this in 3, 2, 1, pause. Alright, so there's a lot of different ways you can think about this, but I made a table with time, skier number 1 and skier number 2. Also, if you didn't notice, there's their feet per second, how fast they're going. So it's time 5, after 5 seconds, skier number 1 is already at 500 feet because he's going 100 feet per second. Skier number 2 is just starting, so he's at 0. And every second passes, so at 6 is at 600 and 110, and so on. I plugged in 30, and then he'd be at 3,000, and he'd be at 2750. And at 50 seconds, skier number 1 is at 5,000, so he's actually done with the course. But skier number 2 has only gone 4,950 feet, so he does not quite pass him in this scenario. Okay, so we're going to be looking at problems like this. This would be an example of a system of equations. So the first thing is a system of equations is two or more linear equations, or two or more equations. System of linear equations is specifically with linear equations. Any ordered pair that makes all the equations true is the solution of the system. You can solve these a bunch of different ways. The first way we're going to do is the graphing method. So first we're going to graph, this is your system right here. Sometimes you'll see that like curly bracket thing there. So we're going to graph each of these lines. I'm going to graph the first one in black, and that's y equals x plus 2. So I'm going to start at 2 on my y-axis, so that's like right here. My slope is 1, because that's the number in front of x. So I'm going to go rise 1, run 1, because I can put a over 1 there, 1 over 1. So up 1 over 1, looks like that, and that, and that, and so on. So I can get my line, draw it through those points like so. That's line 1. Okay, and then I can graph number 2 in blue. So that one's going to get negative 2, so it starts at the y-intercept of negative 2. And my slope is 3 over 1. So I'm going to rise 3, 1, 2, 3, run 1. I can do it again, rise 1, 2, 3, run 1. Okay, so you can see that they are going to cross at that point right there. I'm a little off on my line, oops. Let me try again. Whoa, that's not what I thought it was. One more time. Okay, that's pretty good. Okay, so this, where they intersect, is the only point that makes both equations true. So the solution to this system would be the point of intersection, which is over 2 up 4. So if you plugged in 2 for the x value and 4 for the y value, both of these equations would be true. Alright, so that is solving by graphing. Alright, so now you guys are going to try this one. So graph both of these, see if they intersect, and figure out what the solution is. Okay, pause this in 3, 2, 1, pause. Alright, so the top one is black, the bottom one is blue, and they intersect right on the x-axis at negative 2, 0. So that should work for both of those, and you can plug this in for x, and 0 in for y, and both of these equations should be true. So that is your solution. So when you have a system of equations, you should have an x solution and a y solution, and they combine together to make your system, or your equation solution. I don't know what I'm saying. Anyway. Okay, look at this next one. Scientists studied the weights of 2 alligators over 12 months. The initial weight and the growth rate are shown below. After how many months will they weigh the same? Okay, so with these, I would just set up an equation first. So, actually, let's see. Okay, so let's move that up a little bit. Alright, so your equation you could set up for alligator 1, it's going to be black here. Initial weight would be the starting amount, or the y-intercept, the growth rate would be your slope, so it would be y equals 1.5x, I'm getting that from here, plus it started at 4 pounds, it's a 4-pound egg, when it came out of the egg, I guess. And then the blue one, or the number 2, we'll do in blue. So that's going to be y equals 6 is the initial weight, but it's only growing at 1 pound per month. That's the bell. Plus 6, because that's what it started at. Okay, so go ahead. I'm going to have you graph both of those and see if you can figure out where they cross. So go ahead, pause this. In 3, 2, 1, pause. Alright, so we graph both of these, and it actually intersects off of the graph, so we have to kind of estimate a little bit. But it looks like it crosses at 410, which means that at 4 months, the alligators will both weigh 10 pounds. So, yeah, that's when they'll weigh the same. 410. Okay, let's see. Alright, so this one's talking about satellite service with an activation fee. So go ahead and try to set up these equations and then see if you can figure out where they intersect after you graph them. Okay, so pause this in 3, 2, 1, pause. Alright, so I tried to graph this one, and because you kind of have big numbers and your slopes are very close to each other, the 10 and the 11, it was pretty hard to tell where they crossed at. So I ended up just making a table and figuring it out that way. Sometimes that's just the easier way to do it. And when they're at 5 months, they're both $70. So that's when they're going to be the same. So if you were planning on using it for more than 5 months, you should probably get option 1. If you're planning on using it for less than 5 months, you should probably go with option 2. If you're only using it for 5 months, then it doesn't really matter. Okay. The last thing we're going to talk about is consistent and inconsistent, and dependent and independent. So a system of equations that has at least one solution is consistent. A consistent system can be either independent or dependent. A consistent system that is independent has exactly one solution. For example, the system in problem 1 and 2 are consistent and independent because they both have one solution, like 410 or whatever it was. A consistent system that is dependent has infinitely many solutions. So that's like when we had like all real numbers and whatnot. A system of equations that has no solution is inconsistent. So that's when it's no solution. Okay, so if you look at these, let's do A first. Notice A is in standard form. Well, the first one is in standard form. So I can just cover up the y, figure out my x-intercept, which is going to be -2. So I'm going to go to -2 here on the x. And then I cover up the x. We get 2y equals 2, so divide by 2. So my y-intercept is going to be 1. Like that, and then I can graph that. And kind of like that. I just discovered this handy dandy graphing tool. But it is taking a minute to get to used to using. Okay, so that's the first line. That's going to be this one here. The second one I'll do in black. It's at 1/2 x. This is in slope-intercept form, so I can graph that one just by doing the slope. The y-intercept is at 1. I'm going to go up 1 over 2. Up 1 over 2. Okay, so this one, it looks like it is supposed to be the same line. So, like this. It's probably not exactly because my line's off just a little bit, but it's supposed to be the same line. So if it is the same line, meaning it's always crossing, it's crossing at all the points, then it's infinitely many solutions, or we can say this is an, what did we call it? An identity. So I'm going to say infinitely many solutions, or we can say it is consistent and dependent. Okay, if we do the second one, we have 2x plus 2, so I'm going to go up 2. That's for this one. And then my slope is 2, so I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, and so on. Grab my handy dandy straight line tool, and that's the first one. The second one is at -1, and then it goes up 2 over 1, up 2 over 1, and so on. Grabbing my handy dandy line tool, and then these ones are clearly parallel, so they never intersect, meaning that one has no solution. So we can say that one is inconsistent. So if your two lines are parallel, there is no solution because they will never intersect. Okay, so I'm going to let you guys try A and B here, and then we will see how that goes. Okay, so pause this in 3, 2, 1, pause. Alright, so for the first one, I got those are parallel lines, so that means it is no solution, and we can say those are inconsistent. On the one on the right, I actually just divided this by 3 to get it into slope-intercept form, and it came out with the exact same equation as the first one. So these ones are obviously the same line, so they're crossing infinitely many times, so there's infinitely many solutions, and it is consistent and dependent. Okay, and then C says, before graphing the equations, how can you determine whether a system has exactly one solution, infinitely many solutions, or no solution? Okay, so here's the trick. If they have the same slope, like this, you know they're either going to be the same line or they're going to be parallel. Well, these have different y-intercepts, so those ones are going to be parallel, whereas these ones have the same slope and the same y-intercept, so those are going to be the same line. So that one's going to be infinitely many solutions, this one would be no solution. If they have different slopes, then it will always just be one solution. Okay. Alright, so in summary, one solution, the lines intersect at one point, the lines have different slopes, the equations are consistent and independent. If there's infinitely many solutions, their lines are exactly the same, they have the same slope and the same y-intercept, and the equations are consistent and dependent. And then last one, if it's no solution, the lines are parallel, so they never cross. The lines have the same slope and different y-intercepts, and they are inconsistent. The equations are inconsistent. Okay, that is all for today. I'm going to end this before the 12-minute mark, so adios, see you later, catch you in the next one.